Hi, folks. Welcome back. So, building agents and talking to agents, that's pretty much all I do these days. But as I do that, one of the things I think about a lot is how to teach this stuff. How would you systematically teach how to build good agents? How would you construct a course, so to speak, that teaches people how to build agents? You could say this YouTube channel is basically an attempt at trying to do that. I've also put out resources like harnesscourse.com. I'll leave a link to that down below. And harnesscourse.com teaches people about prompt engineering, context engineering, harness engineering, these kind of three increasing levels of complexity. But harnesscourse.com, I would say, is very much a grad level course in that it is a high level organization of papers and blog posts and articles on these topics. So it puts some organization around all these papers that you might otherwise haphazardly run into and puts it out in a structured, sequenced way. But I've also been thinking, well, if you wanted to construct an even more basic course, kind of a 101 level course, how would you do that? How would you make a course that builds this up more from systematic primitives? And to that end, I've put out something I'm calling Agent Atoms, agentatoms.dev. It's very much inspired by the notion of a periodic table that we see in chemistry, in that you have elements and the elements combine into molecules using bonds. And so, what I've been thinking about is what are these atoms? What are these primitive elements of agentic behavior? Things that turn up very commonly, that are very basic and fundamental to building agents. Of course, there's prompting and verification and delegation and looping. There are various control structures, there's retrieval, there's tool calling. So you have all these very basic primitives, and you combine these primitives in various ways to construct agents, just like atoms combine to form molecules. And the ways in which they combine also come in a number of varieties. You could, of course, just sequentially compose them, but you could also have checks or guards or preconditions. You can have loops, you can have conditions. So there's different kinds of so-called bonds between these elements that you could combine to form molecules or functional groups. So that's what I'm trying to do with agentatoms.dev, to essentially construct a periodic table of agentic behavior, to really break it down to its primitive, most basic parts, and then show how you can compose them to build more complex functionality. And then I took it a bit further and I built a compiler or interpreter for these agent atom expressions. You can call it an algebra. It's an agent algebra where you can write out these expressions. And so there's a playground off of the website. And on this playground, you can actually write out these agent algebra expressions where each term of the expression is one of these very basic agent atoms. And so I think that might be a useful way of trying to teach and learn agentic behavior from very basic first principles. So obviously, I'm leaning very much into this whole metaphor of the periodic table. Another thing I was very inspired by is Ken Iverson and APL. Ken Iverson was a Turing Award winner, most known for this programming language called APL. You should check it out if you haven't seen it. It's this really dense programming language meant for mathematical operations, especially matrix operations. And you can express in one line of APL what would otherwise take maybe a few hundred lines of code in any other regular programming language. But I think his Turing Award acceptance speech was titled Notation as a Tool for Thought. And the point he was making in that talk was that, look, notation is really important because it lets you think in new ways. It lets you treat a problem in new ways. And it lets you basically think and express things that you couldn't without that notation. So that's what I was inspired by in trying to come up with agent atoms as a pedagogical resource. Now, of course, it has a lot of simplifications. I personally I personally think it can express maybe 80 to 90% of most real world agents, but maybe I'm saying that just because it's my baby. But yes, there are a few simplifications. It doesn't have very complex context management. It's simplified a few things. And there's certainly very complex agent structures that maybe you can't express with these elements or you can't express with this agent algebra. You could also argue about the choice of the elements, what is an element, what isn't an element. Maybe some got left out, maybe some shouldn't be in that list of elements. So I think you can have a useful debate around the margins of what should be an element, what actually is an atomic primitive chunk of agent behavior. But nonetheless, even with the elements that are in there, I think it could serve as a useful tool for learning and teaching agents. So check it out, read it. You can even play and execute agent algebra expressions in the playground. I would love to get your feedback. The GitHub repositories and code and the page itself, it's all open source. I'll leave a link to all those repos down below. And yeah, I'll see you in the next one. Thanks.